Hello there, folks. Hey, this is Joe Wazoo here. Hey, this video is going to cover some scaling thoughts or some scaling ideas that you can do within Redline software. I was dealing with helping a customer the other day, and we were doing a bunch of scaling things. It was very confusing, so I thought I would do a video on how the scaling works. So if you look here, team, I'm going to start off first. I've got a tag. I'm going to pretend here. I've got a tag here that is simulating a 4 to 20 milliamp signal as a real number. And I want you to notice that the pi symbol here, it's internal. I'm not mapped to anything, so I'm just playing around here. If I go to the Format tab, you can see I got the minimum value set to 4.0, the maximum value set to 20.0. Got 2 digits before, 2 digits after, and then I think, oops, I made a change to that by accident by just sliding my mouse. If I slide down here, I got milliamps here. Okay, so that's my simulated value right there. If I go to the next tag over here, I've got one here called raw 0 to 20. And if I click on the data tab here, you can see what I did is I really just grabbed this guy and drug it right there. That's all I'm doing. I'm assigning that. It's a very simple formula tag equal to that one. However, the reason I'm doing that is because on this one, I am going from a minimum 0 to 20 milliamps difference. And the data tab, I'm not doing anything. So I just want you to notice that. Okay. And then I went a step further and I said, all right, what if I wanted to scale that number between, say, a 15-bit resolution device and a 16-bit resolution? What I mean by this is some products, when you look at them online, they'll go from 0 to 32,767 if they're 15-bit resolution. And if they're 16-bit, they will go from 0 to 65,535. So what I'm doing here on these two scales, or these two tags, is I made them integer tags with an X here, treat as a floating point, but then I'm scaling to an integer. So I'm taking the raw 0 to 20 milliamp number, and I'm going to either scale from 0 to 32,767 if it's 15 milliamp, or to 65,535. Let's look here on the format. Okay, so the format tab, I'm just following the same thing there, that number there. All right, so that's what I got going on here. On display pages, what I've done in display pages is this is the raw number we're going to play with. In this case, this is the other number that's on there, and these are the scaled. And then I drew up some different graphs that'll show this. So let's go ahead and save this. Let's go ahead and download this to our existing HMI here. All right, and let's go look at our HMI. Here it is. Let me make this a little bit more square. All right, see if it loads in here. All right, so I want you to notice right now, team, that I come in here, I got 0 milliamps here. Everything's 0 here. So if I click here and put in, well, if I try to put in 3 milliamps, you can see the limit here barks at me. If I put in a 4, all right, so now we're seeing something interesting. 4 milliamps is the bare of this one here, the base of this guy. So this is a 4 to 20 milliamp scale here. This scale here and this scale here is going 0 to 20 milliamps. So notice when I put a 4 in here, all of a sudden it starts to show up here, but it's the very bottom of this. And I also want you to notice something interesting. These numbers here are the decimal equivalent of that. So this one goes from 0 to 32,767, which is this yellow trend right here. And this one here is 0 to 65,535 is this pink or fuchsia color here. And then I did another, I put it also vertical like this here. So you can see it, I'm sorry, horizontal like this here as well. So here's the horizontal version of this, and here's the vertical version. So if I change this number to 8 milliamps, you can see it follows there. What if I change this to 12? So 12 is the middle of this area right here. And if I change this number to, say, 16 milliamps, there it follows. And of course, I take it all the way to 20, full scale all around. The interesting thing is I want you to notice that happens with these numbers, because this is where people get confused all the time, particularly when you're taking a 4 to 20 milliamp signal into a 0 to 20 milliamp device. Where does it start at the 4? So if you see I put in a 4 milliamps here, you can see here that on that scale, 13107 will be the minimum, at 16-bit resolution, and 65535 would be the beginning at 0 to 20 milliamp in a 15-bit resolution. So that's what I'm doing there on that example. Let's go a little step further. Let's go over here to Crimson, and I went another step. I went ahead and created some other tags to look at a 0 to 10K analog input. You might wonder, where did I come up with the 0 to 10K? Well, with the Redline products, some of them will scale from 0 to 10,000 over the analog input. For instance, if I go over here to this other version of Crimson, if I go over to this G09 I've got here, go to IO modules, and on the G09 I happen to have a UIN 4-channel universal input here on channel 1 or module slot 1, and then I happen to have an 8 output on slot 2 here. So let's go ahead and add this guy here. Analog output right there. Perfect. So I want you to notice the Redline does this all the time. They have these 0 to 10,000 numbers in here. And if I go over to this guy, my analog input, and you can see right here, now I'm saying the word 10,000. I'm going to be honest here. But it shows up as 100.00. But in reality, it's an integer value, 0 to 10,000. If you remove that decimal point, this number is 10,000. So what I did in Crimson is I went a step further, and I added the same thing here. I added an internal tag that is going to mimic that analog input. Notice I got 0 to 10,000 here from my range. Data tab, it's internal. I went to 15-bit. I did the same thing here, 3267. 16-bit, 0 to 65535. And then I went ahead with these two here, and I scaled them as a 0.0 to 20.0 for my milliamp, and this one here is a 4 to 20 number here. One thing I will tell you when you're doing this scaling here, if you go to the Format tab, by default, Crimson will automatically allocate 5 digits before the decimal point and none after. So you have to give it a proper assignment here. Otherwise, it won't show any decimal points. So this is all going to happen on this page, int to 10K. So let's go ahead and look at our simulator for this by clicking this button right here. Maybe get this thing in my way. There we go. Okay, so now if you look here, let's say I put in a number 5,000 here. So 5,000 is definitely the halfway point between 0 to 20 milliamps. So that's what I'm getting there. There's the halfway number. If I change this to something else, now that's interesting. Look at that. I put in 2,000, but this chart here is supposed to go to 4 to 20 milliamps. So it doesn't even show up here. And I tried to draw this line to kind of help you visually see what I'm showing here. So the yellow line is this one here. I don't have a purple, but this is the red one. So if I take this to 3,000, that takes it to 6 milliamps, and that starts to show up here. So that's just kind of an interesting point about those numbers, how that scaling works. Again, that's all happening at the data tags here on the Format tab. Right here, I'm doing the scaling here. So this one is going 0 to 10,000 is our input, 0 to 32,767 for the 15-bit resolution, bit 16, 0 to 65,535, and then these two, I'm trying to show it as a 0 to 20 milliamp and a 4 to 20 milliamp number. All right, let's go a step further. Let's try something real here. So since I have this other screen plugged in, I actually have an analog input on channel 1 of my analog output, this guy right here. Let's change this part number to GMOUT4. Oops. There we go. And then this one, here's the part number right here, is a GM graphite module UIN4. It's a 4-channel analog input. All right. So if I click on the GMOUT, I actually have a 0. I'm going to do this in current, so I'm going to do 0 to 20 milliamps here. So if I hit the pull down here, actually before I do that, I want you guys to notice what's happening right here. Just pay attention to that. I'm going to switch this to a 0 to 20 milliamp. There you go. Notice that stayed 10 milliamps. I want to point that out to you because that threw me for a loop earlier. So I'm going to take this this output, and I want to wire it to input 1 on this thing. So I got a direct wire. I'm going to go over here and say, you know what? This is going to be a 0 to 20 milliamp current. All right. So that looks good. Let's go back to data tags over here. Let's create a data tag here And let's call this one AI_1 for channel 1. And on channel 1, I'm going to hit the pull down here. I'm going to go down to my GMUIN4. I'm going to go to input objects, status group, and I want to look at what's happening on channel 1. So that's going to be PV1 process variable 1. I'll click the OK button. Notice it went green. Perfect. Let's go ahead and create another tag here. And let's call this one AO analog output underscore number 1. Enter. Notice it's blue because it's not mapped to anything. Hit the pull down here. Go down to GMOUT4. We want to map this to the output. We're going to go to the data point, and we're going to go to data 1. This should be the output here. So go ahead and click the OK button. Notice it's red because it's writable. That's what I want. I'm going to leave everything else on here default. So let's go over here to display page, go to data tags on the right. I'm going to highlight both of these guys, both these tags, drag them both out here like this. And let's make this a little bigger like this so we can see it. All right. So I'm going to double click on this one. Boom, 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 boom. Make it bigger. And since this guy is green, I'm going to double click on it, go to the edge, and give the border a green color, indicating analog input. And then this one, watch this cheat. I want to copy from here to here. I'll right click, copy from, copy all formatting, notice the X, click here, boom. But I want to make this one have a red border. So double click on it. All right, let's see what happens here. I want you to pick up on something. I'm going to go ahead and get this thing out of my way. There we go. All right, let's download this to it. All right, so we're downloading to it. Should be this remote testing program. All right, so notice 0, 0, perfect. Now, if I put in a number here, oh, I can't do it here. Put a number in here. Oh, you know what I forgot, team? I forgot to make this date entry. And you can always tell because the corresponding background color. So that's why the keyboard didn't come up. Let me go ahead and download this to it. There we go. I didn't do any formatting on the tags here at all. I just want you to see something. So if I click on this guy and put in a number, say 5,000, I want you to notice something. Very interesting. The input comes up to about half that value. And I thought that was weird. What if I put in 10,000 here? Oops, not 1,000, not 10,000, sorry. So it goes up to half the number. If I put in any bigger number, like that, oh, look at that, rolls over. Okay, well, that's probably because something would buy. All right, so important thing here I want you to notice is that at 10,000, it only goes to halfway. And this really threw me for a loop with this product. And here's what it came down to. If I go back to here, and if I look at my output, when I change this from voltage to current, for some reason, it leaves this field at 10.0. This probably is a little mistake. It should have went to 20, but if I change this to 20 milliamps like that, hit enter, go ahead and download it. Now, when I run this, let's look at our web page here. Should come back to 0 because I don't have anything set to retentive. Okay, there you go. So watch, if I put in 5,000 this time, it should be pretty spot on. And it sure is. And if I put in 10,000 this time, it is. Perfect. All right. All right, so what if I wanted to show these numbers as a 0 to 20 milliamp value? Because that's what they are right now. So if I go over data tags, and here's our analog output. Now we know, honestly, if I go to format tab, we know that the minimum value for this guy is 0 to 10,000 here. And we also know if I go to analog input, I might as well just match because we know that it's going from 0 to 10,000 here as well. Right there, okay? So if I wanted to show my analog input as a 4 to 20 milliamp number, I could click on the data tab. Notice this is mapped here, and go down here to where it says do not scale. I can choose scale to floating point. I know this is coming in as a 0 to 10,000. So I'll put those numbers in there. I think I'm off by a 0 there. Okay. But I want this to show up as a 0.0 to 20 milliamps. So if I go 0.00 to 20.00, notice the symbol change to a pi here. Okay. If I slide down a little bit here, I'm going to use the simulation, put in 12.34 just to simulate while I'm in Crimson. If I click back on display pages, notice everything looks normal here, but when I take my mouse and click here, watch what it does. 1, 2, 3, boom. Okay, so it shows up there. Let's see if this works correctly. Let me go ahead and download this to our screen. Let's see what it does here. All right, so it's sitting at full scale right now for some reason. Let's put this at 0. Okay, that worked good. If I put this at, say, 5,000, now you notice that little flicker, and you can kind of see 1, 2, 3, 4. You can almost see 5, maybe 4 spaces here. Well, if I wanted it to always have 2 digits before and 2 digits after, what I'm going to do is I'm going to go back to data tags here. And on my analog input, if I go to the Format tab, I'm going to hit the pick button right here and declare this as a numeric. And now down here, I can say this guy should have 2 digits before. Whoops. Go down here. And 2 digits after. And honestly, this now, well, I'm not doing any trending. This would show up on a graph. And if I go down here, I can put in M, little m, big A for units. Go back to display pages. I'll click here, 1, 2, 3, boom. Throws the little M in it. Let's see if this works a little better. So it's sitting there. Okay. If I put this at, say, 2500, there you go. Perfect. Just play. Okay. Wonder if I could try to do the same thing here. Let's look here. If I go back to data tags over here. So this is my analog output. And I want to make that number be 4 to 20 milliamps. So let me ponder my thoughts here. Okay, so that's tied to that. I'm going to try something. I'm going to play here and do scale to integer. It's going to sound weird, but I'm going to put in 0 here to 2000. I'll explain this in a second. And I want this to, see, this is where I'm thinking. I really want to go, now let's try it. Let's try that. All right, let's just try this real quick. I don't know if it's going to work, but I got some work to do on this example. Because that display from is what it's going to display. Let's see what it shows here. Yeah, that is not quite what I want to do. Nope. All right, well, I'm going to work on another video of that concept. But anyway, I just thought in this video I would go through some scaling, give you a chance to see what I'm doing here, particularly on this part over here. I really wanted you to take away that these raw numbers, depending on your scaling, will determine where they start. If they're 0 to 20 milliamps, 20 milliamps in here will determine that particular thing. So anyway, hey, thanks a lot, folks. Have a great day.